Friends, I am Dr. S.P. Patil. So in this video, we discuss about the classification of optical fiber. Now, on the basis of mode of propagation, the optical fiber divides into two types. First one is single, or we can say that monomode optical fiber. Okay, and second type, that is multimode optical fiber. Understood? Now, on the basis of refractive index, this optical fiber classified into two types. First one is step index optical fiber and second graded index optical fiber. Now, initially we discuss about single or monomode optical fiber. Okay. Now, this single or monomode optical fiber has very small core diameter. If you see this figure, first figure, then it is observed that core diameter is very small and which is about 8 to 10 micron. Okay. Now, another thing, this single optical fiber support only one mode of propagation. That is, if you see this second figure, then it is observed that this single optical fiber carry only one wavelength along their length. See this. Understood? That is, it carry only one light along their axis, and that is nothing but the single or monomode optical fiber. Understood? Now that wavelength is vary from 1350 nanometer to 1550 nanometer. Okay. Now this single optical fiber also has high bandwidth, or we can say that higher information capacity. Okay. This optical fiber transmit information to longer distance due to negligible dispersion, or simply we can say that this single optical fiber used for a long distance for communication purpose due to their high bandwidth without any loss of intensity of light. Understood? Now this single optical fiber has disadvantage also, and that disadvantage is that it is very much difficult to launch the light through the fiber, because already I told you the core diameter is very small, and due to this reason it is very much difficult to launch the light through the fiber. Understood? So this is about the single or monomode optical fiber. Now second type, which is based on the mode of propagation, that is multimode optical fiber. According to their name, multi means if there is a more than one, then it is nothing but the multi. Okay. So this type of fiber has large core diameter. If we see this first figure, then it is observed that the core diameter is around 50 micron. 50 micron. Okay. Now, and this optical fiber support larger number of mode of propagation. If we see this second figure here, if we see there is a more than one light beam is there. Understood? And hence we can say that this multimode optical fiber support large number of mode of propagation. Okay. And the wavelength of this type of fiber in visible spectrum ranging from 850 nanometer to 1300 nanometer. Okay. And this type of fiber can be used to transmit signals only for short distance. And due to high core diameter, this multimode optical fiber is due to high core diameter, the launching of light is very easier. Understood? Okay. Now based on the refractive index, optical fiber divides into two types. Now first one is the step index optical fiber. Now here we can see it has a very thin core of uniform refractive index. If we see this figure, then it is observed that the refractive index of core is uniform. Okay, and here we have considered by mistake it happened here n1 I have considered and that is equal to 1.5. Okay, sorry, and that core surrounded by another region, that is cladding, having refractive index is n2. And always I have told you, always keep in mind refractive index of core is greater than refractive index of cladding. Okay, now next, here the refractive index abruptly changes at core cladding interface, so it is known as a step index optical fiber. If we see this figure, then it is observed that this is the refractive index of core and this is the refractive index of cladding. And here what happened, core cladding interface, there the refractive index abruptly changes, see, okay, and that is nothing but the step index optical fiber. Okay, now core diameter is 2 to 8 micron. Now in this type of fiber, the core diameter is around 2 to 8 micron and cladding diameter is about 125 micron. Okay, one more thing is there, they have low value of numerical aperture and hence low acceptance angle. Now about a numerical aperture and acceptance angle we'll discuss in next video. Okay, now second type, which is based on the refractive index, that is nothing but the graded index optical fiber. Now here what happened, the refractive index of core gradually decreases with the distance from the fiber axis. See this figure, then it is observed that this is the refractive index of core and this is the refractive index of cladding. Now what I am telling, that is refractive index of core gradually decreases, okay, with the distance, radial distance. Okay, now refractive index at the fiber axis is maximum, but what happened, the refractive index at the axis is maximum while it is minimum at the core cladding interface. Understood? At the axis that refractive index is maximum and core cladding interface the refractive index is minimum. Okay, now that is at the interface the refractive index of the core and cladding are equal while it varies with the distance between the fiber axis and the core cladding interface. So this is about the graded index optical fiber. One more time we'll discuss about types of the optical fiber. Okay, now already I have told you on the basis of optical fiber, on the basis of mode of propagation, optical fiber divides into two types. First one is the single, or we can say that monomode optical fiber. Okay, now this single optical fiber has very small core diameter, which is around 8 to 10 micron. Understood? Why it is called as a single or monomode optical fiber? Because mono means single, so and single means one. So this type of fiber support only one mode of propagation, that is it carries only one wavelength along their length, and hence it is known as a single or monomode optical fiber. Understood? Now that wavelength is vary from 1350 nanometer to 1550 nanometer. Now this type of fiber has high bandwidth, or we can say that higher information capacity. Okay, and this type of fiber particularly used for a longer distance for transmitting the information without any loss of intensity of light. Now this type has one disadvantage also, and that disadvantage is due to small core diameter, it is difficult to launch the light into the fiber. So this is about the single or monomode optical fiber. Understood? Now second type is multimode optical fiber. If you see this figure, then it is observed that in this type of fiber, the core diameter is large. Understood? And which is about 50 micron. Okay? And why this type of fiber called as a multimode? Because if we see this figure, then it is observed that this type of fiber support more than one beam. See, this is one, this is another, this is third one, and hence it is known as a multimode. Or we can say that this type of fiber support large number of mode of propagation, and hence it is known as a multimode optical fiber. The wavelength in visible spectrum ranging from 850 nanometer to 1300 nanometer. So this type of fiber used to transmit the signal only for short distance. But here in this type of fiber, due to high core diameter, the launching of the light is very easier. So this is about the multimode optical fiber. Understood? Now, based on the refractive index, optical fiber divides into two types. First one is the step index optical fiber. So what happened in step index? According to their name, step index means what? The refractive index stepwise varies, and hence it is known as a step index optical fiber. Here, this is the refractive index of core, which is around 1.5. Okay, and this is the refractive index of cladding, and which is around 1.48, which is lower than that of core. Understood? Now here what happened? Refractive index abruptly changes. Now here there is a n1 refractive index, but this refractive index abruptly changes due to the core cladding interface, and that is nothing but the step index optical fiber. Okay, so core diameter here is around 2 to 8 micron, and the cladding diameter is around 125 micron. Okay, this step index optical fiber have low value of numerical aperture, that is Na, and hence low acceptance angle. Understood? Now second type is graded index optical fiber. Now here what happened? The refractive index of core is gradually decreases. Okay, and hence it is known as a graded index fiber. Understood? And along their axis, the refractive index is maximum, while core cladding interface, that refractive index is minimum. Okay, and that is nothing but the graded index optical fiber. Thank you.